Welcome to iLectureOnline. Here's our third example of how to use the superposition principle in order to solve a circuit. Now in this particular case, I would think that it's probably easier just to go ahead and solve this circuit right away instead of trying to do it in 3 different steps. But this is simply for illustration purposes. You can see how nicely it can work in any situation. Here we have a circuit that has 3 sources, 2 voltage sources and a current source. So what we're doing here is separating that into 3 separate circuits, each only carrying one of these sources. Here we have the current source, here we have one of the voltage sources, there we have the other voltage source, and the other sources are not present. Notice that when we remove the current source, we open the circuit at that location. When we remove a voltage source, we simply have a short in the place of the voltage source. All right, let's go ahead and solve the 3 different circuits separately. What we're trying to do here is, here it is, find the current through the 3 ohm resistor. Using mesh currents and going around each mesh, let's go ahead and see what we get here. For I1, let's start at this corner right here. We have a drop of minus 8 I1. Coming around here, we have a drop of minus 4 I1. But we have an I2 in the opposite direction that would be minus I2 like this. Notice that this negative will make that into a positive. And then coming around here, we have a minus 4I1. And we have to subtract the I3 from it. Yes, because it's in the opposite direction. Minus I3 like that. And that adds up to 0. Doing that again for the, well, let's simplify things first. First of all, we know that I3 is equal to 3 amps, so we can put a 3 in there and simplify the rest. We have minus 8I1, minus 4, and minus 4. That's minus 16I1 plus 4I2 plus 4I2, and minus 4 times the minus 3, because this negative makes that a negative, that would be a plus 12 equals 0. Here's our first equation in this first circuit. Now let's go for the second mesh. Coming around here, starting from this point, we go here, we have a drop across the 3 ohm resistor, minus 3I2, but I have to subtract the I3 from that, minus I3. And then going around this here, we have minus 4 times I2, but I have to subtract the I1 from it. And that adds up to 0 when we go all the way around the circuit. I3 is 3 amps. Minus times a minus makes that a plus. We end up with a minus 3 and minus 4, minus 7 I2. We have a plus 4 I1. I think I'm going to reverse the order of those. I like to have the I1 first and I2 second. So plus 4I1 minus 7I2, and 3 times 3 is 9. That would be plus 9 equals 0. There's our second equation. And then our third equation, well, I3 is equal to 3, right? I3 is equal to 3, so we don't have to do anything there. That's a known quantity. All we have to do now to solve for I1 and I2 is solve these 2 equations simultaneously. What I need to do is multiply this times 4, because then I'll have 16I1, have a minus 16I1. When I add the 2 equations together, the I1s will cancel. I'm going to multiply this times both sides of the equation times 4, which gives me 16I1 minus 28I2 is equal to, when I move that across, that would be minus 9 times 4, minus 36. Adding that to this equation, minus 16, so this equation comes down here. Minus 16I1 plus 4I2 is equal to, bring the 12 across, it becomes minus 12. Add those together. The I1s drop out. I end up with minus 24I2 is equal to minus 48. I2 is equal to 2 amps. And then I need to use one of those equations to solve for I1. I think I'll use this equation right here. So 4 times I1 minus 7 times I2, which is 2, plus 9 equals 0. And do I really care about I1? Well, I don't really care. I could calculate for I1, but I really don't care, because I'm only concerned about the current through here. That means I need to know I2 and I3. I don't need to know I1 in this case, so I can just stop right there and not continue. Moving on to the second circuit, I have two meshes, starting with mesh 1, starting at this point right here and going around the circle, or it's not a circle, the rectangle, minus 4I1, but I have to take into account I2, that would be minus I2. This, minus 4I1. I don't have to worry about I3 because there's no current there, the current source is gone. Minus 8I1 plus 24 equals 0. Simplifying that equation, I have minus 4, minus 8, that's minus 16I1 plus 4I2 is equal to, when I bring the 24 across, I get minus 24. Okay, there's my first equation. My second equation using mesh 2, going around like this, I have minus 3I2. I don't have an I3, so I don't have to worry about that. Coming across here, minus 4I2, and I have to subtract I1 from that, and that equals 0. Simplifying this, I have 4I1 minus 7I2 equals 0. There's my second equation. Now I have to solve for I1 and I2, in particular I2. I don't really care about I1. I have to solve for I2. I can do that by eliminating I1, multiplying this equation by 4. That'll give me 16I1. Add to this, I1s will drop out. 16I1 minus 28I2 equals 0. Bringing this equation down here, I have minus 16I1 plus 4I2 equals minus 24. I1s drop out. Here I end up with a minus 24I2 equals minus 24. Therefore, I2 equals 1. Notice in this circuit, I2 equals 2 amps. In this circuit, I2 equals 1 amp. Is that a contradiction? Not at all, because they're two very different circuits. They have very different sources, different arrangements, so that's quite all right. In the end, when we add them together, we just want to make sure that we have the right direction in each case when we add them up. Then I go over here and solve for I2 in this circuit. Using mesh 1, I have, starting at this point right here, minus 8I1, minus 8I1. Coming around here, minus 4I1, but I have to subtract I2 from that. Coming across here, I have minus 4I1. I don't have to worry about I3 because there's no current source, equals 0. Simplifying that circuit, or I should say that equation, minus, that's minus 16I1 plus 4I2 equals 0. There's my first equation. Second equation using mesh 2, starting at this point right here, coming across here, that's minus 3I2, minus 4I2, but I have to subtract I1 from that. And then coming across, minus 12 equals 0. Simplifying that, taking I1 first, that's 4I1, minus 3, minus 4, minus 7, I2 equals, when I take the 12 across, it becomes a plus 12. Solving those simultaneously, again, I'm going to multiply this equation by 4. When I do that, this becomes 16I1 minus 16I1. When I add them together, the I1s drop out. 16I1 minus 28I2 equals 4 times 12 is 48. Bringing this equation down here, I get minus 16I1 plus 4I2 equals 0. Adding those together, that drops out. Minus 24I2 equals a positive 48. I2 equals minus 2. And that would be amps, of course. I have 3 values for I2 And if I3 is important, like in this case, of course, I know that I3 is equal to 3. I can now go ahead and solve for I in this branch by simply adding up all the currents running through that branch. I is equal to, from the first circuit, notice that I2 is in the opposite direction of the current that I want the current downward. I2 is upward there, so I take the negative of I2 in this case. So negative I2 would be a minus 2 amps. But I take the positive of the I3, because it's in the same direction. I know that I3 is 3 amps in that circuit, so plus 3 amps. That's from the first circuit. From the second circuit, notice I only have one current, I2 in this direction, but notice I want the current in this direction, so I'll take the negative of that, negative 1 amp. Now I go to the third circuit. Notice that I2 is in the opposite direction from what I want. I2 is a negative 2 amps, so I take a negative times a negative 2 amps. Negative times a negative 2 amps. When I add it all together, minus 2 plus 3, that's a plus 1, 0. Minus times a minus is plus 2 amps. I equals 2 amps, which is the final result. That's the current in the 3 ohm resistor in this particular circuit. Wow, that's a lot of work. When you spread out over 3 circuits and you have to solve each circuit separately, that will take some time. But again, for illustrative purposes, you can see that the superposition theorem works really well. You can separate the circuit into 3 different circuits, only having one of the sources in each case, calculating the current through that particular branch in each of the 3 circuits, add it up together algebraically, and you do get the correct result in the current through the 3 ohm resistor. And that's how it's done.